Good morning, guys. It's Ms. Seifert. It is Saturday morning, and I am coming to you from my house because what do I do outside of school? I sit around and I grade papers and I write lesson plans. And I was looking at the papers from this week, realized that with the test coming up next week, we haven't exactly mastered some of the stuff that's going to be on the test related to plate boundaries and the different landforms. So, just a quick review of those for you. Tectonic plates, we talked about how Earth's lithosphere, which is the upper mantle and crust, is broken up into plates. Plates are in motion due to convection currents in the asthenosphere, which is the middle layer of the mantle. Plates lie under the ocean floor and or the continents. So the ocean floor is usually basalt and more dense, and continental land is usually granite and less dense. Less dense means it's going to rise. Plates move against each other in three major ways. They could have convergent plate boundaries, divergent plate boundaries, or transform plate boundaries. So we're going to go through all of this stuff. Earth's layers, right here you can see the lithosphere is made up of the crust and the upper mantle. And then the asthenosphere, the part that is moving and has convection currents, is below that. Okay, so what this ends up looking like, we've got these plates on the outside of the Earth in the lithosphere, which is, again, the crust and the upper mantle. And then you have the asthenosphere, or the moving part of the mantle, and we see these convection currents where they're getting heated down here, become less dense, that magma rises, then it loses some of its heat as it moves along, it becomes more dense, and it sinks again and gets reheated. So again, these convection currents were the part that Alfred Wegener was missing when he first proposed continental drift, and of course got ridiculed because he couldn't explain how things moved. This is again based on indirect evidence that we have from volcanoes. Earth's plates. Well, there are a lot of different renderings of them, and frankly, there are a lot of plates. You can see these two maps came from different sources, and they have some variations. This map over here shows the Gorda plate, where this one shows the Juan de Fuca plate. This one shows the Scotia plate, this one does not. This one has the Iranian plate versus the Arabian. This one just shows the Arabian. So the question then becomes, exactly how many plates are there, Miss Seifert? Like, there's got to be an exact number. And science sometimes is not exact. We've got major plates, we've got minor plates, and there are a whole bunch of teeny tiny plates. So it just depends on which map you're looking at. And I would suggest that if you're consulting a map that might appear on your test, that you'd look closely and be able to count the plates, because not all maps that show all the plates all over the Earth are going to show all of the minor plates. I would again direct your attention to consulting the map that you might see. So, convergent plate boundaries. These plates are heading toward each other. The stress here is compression as they run into each other, and they can make different landforms, which you can see over here. But let's go into each one. If two continental plates run into each other, we end up with mountains, and specifically folded mountains. Neither plate really wants to go anywhere, so they bump into each other and push upwards. Imagine like two cars running into each other. Both front ends are going to get pushed upward, and so the same thing happens with our mountains. So examples of these, the Himalayas, the Alps, the Rockies, the Andes, even the Appalachians are very old folded mountains. Okay, if you have oceanic crust and then continental crust that run into each other, the oceanic crust is denser, and so it's going to subduct. It's going to get pulled under. What we find off the coast here is a deep trench, and then we see volcanic activity inland because, these plates are huge. Moving downwards like this creates a lot of stress, creates a lot of heat. And so we do see magma coming upwards into lava, some volcanic activity. So these are known as subduction zones, where you've got one plate subducting under another. Examples, the Cascadian subduction zone, which is in the Pacific Northwest. And there's some concern there in terms of what continued subduction will mean, because there has not been a lot of volcanic activity. Well, there's been volcanic activity, but not any major earthquake activity in a while. Oceanic and oceanic, two oceanic plates running into each other. We're going to get a trench again in the middle of the ocean, We're also going to see volcanic activity, but because it's out in the ocean, we get a volcanic island arc. And these do tend to be curved. Again, the denser plate is going to subduct. That's usually the older plate. And so we're going to see a chain of volcanic islands. Some examples, the Aleutian Island arc, which comes off the coast of Alaska, Japan, and the Philippines. So again, some volcanic activity, earthquakes, and these islands in the middle of the ocean. Okay, now divergent plate boundaries. These are being pulled apart. They're pulling away from each other. So the key stress is tension, kind of like if you're pulling on either end of the rope, that creates tension. So the landform you get depends on what type of crust is involved. In an oceanic situation where you've got two oceanic plates pulling away from each other, you get what's called the mid-ocean ridge. So magma is seeping up, and as it hits that ocean water, it's solidifying into new ocean floor. It's moving outwards from there, and it's actually pushing continents away from each other. So the North America and Europe are moving away from each other like 3 inches a year. Not huge amount, but definitely something. And we talked about how Iceland actually is on top of that mid-ocean ridge, and therefore they have a lot of geothermal activity and can use that for their energy production. Continental divergent. If you have continental crust pulling away from each other, you end up with a rift valley. There's volcanic activity that's occurring along this valley. You may also get, water attaching here. Examples are the Great Rift Valley in Africa, as well as the Thingvellir fracture zone in Iceland, because again, Iceland's on that mid-ocean ridge, but it is continental crust right there. So over time, a rift valley could become a mid-ocean ridge. You could have continental movement outward, and so you've got that deep valley, which is going to fill in with water. If you end up with seawater coming in there, because eventually it's going to rift all the way to the ocean, you end up with that trench right there. I'm sorry, not a trench. You get the Rift Valley, but it's underneath seawater. Well, over time, that Rift Valley underneath seawater could become a mid-ocean ridge. It's kind of a big deal. Kind of surprising, but yeah, it makes sense. So transform plate boundaries. This is where you've got two plates. They're not moving towards each other. They're not moving away from each other. They're just slipping past each other. Imagine if you bumped past somebody in the hallway. So the stress here is called shearing. Neither one, again, moving up and down, but we're going to see a lot of earthquake activity. This is what's happening at the San Andreas Fault in Southern California. We're also seeing this at the Alpine Fault in New Zealand. And it says click to play animation. You're not going to see the animation, but you can look up more about transform plate boundaries. Again, typically a lot of volcanic activity are happening around them. Okay, so summary here, quick video. As the plates move, we see three primary types of boundaries. The convergent boundaries are pushing together. They're experiencing compression, and this gives us folded mountains or a subduction zone. Divergent, they're moving away from each other. They're experiencing tension, and this is going to give us a rift valley or mid-ocean ridge. And transform boundaries, this is where the plates are slipping past each other, experiencing shearing, gives you a transform fault and lots of earthquake activity. Wait, there were random bolded words and things in the slideshow because those are important. And there's a test coming. I'll let the dog give you a hint. Hope all is well. Enjoy your Saturday, and I will see you guys on Monday.